Well, let's continue the rest of the part as we were discussing in the last class about the direction, which is nothing but we have four directions: north, south, east, west. And apart from these four directions, we also have a quadrantal directions, which is nothing but we call it as northeast, southeast, northwest, southwest. Right? And direction is really important because we follow one particular path. Let's say if you want to go from A to B, all right, so you will have to maintain one particular track or a direction to reach to that point. If you maintain another direction, you end up reaching to some other place, right? So you as a pilot, you have to be very strict and disciplined to maintain a direction of your aircraft, for which you will have a lot of references in the cockpit, what heading or what track you are flying, and eventually it takes you to the point where you intend to go, right? So yeah, before we move to that, we have few terminologies that you have to remember. There is nothing but cardinal points and quadrantal points. So as it's described here, what are cardinal points? Okay, so let me tell you before that, as we move towards the direction, all right? So we say a direction has 360 degrees, all right? Let's say if you're going into this direction, we call it that you're going in the direction of east, or we call in the direction of 90 degrees, 090 degrees. Similarly, we have total 360, so this becomes south, which is nothing but 180 degrees. This becomes west, which is nothing but 270 degrees, and this becomes north, which is nothing but 360 degrees. Or we also call it as 000. So either you call it as 360 or 000, it means the same. So if you see, there are directions. If you move in the clockwise, all right, let's say you're going from north, you're moving in a clockwise direction. So if you go in a clockwise, what is happening to our direction? Is it increasing or decreasing? Obviously, yes, it is increasing. If you see the numbers, 0, 10, 20, 30, 40 to 90, further to 100, 140 to 180, right? So if you go in the clockwise in the direction of right, let's say you fly rightwards, the direction is increasing. If you go reverse, what I mean to say is, if you go opposite to this, let's say you fly opposite, all right? So if you move anti-clockwise, your direction starts decreasing. So south, east, 45, 30, back to 0, right? So clockwise movement will increase your direction, anti-clockwise movement will decrease your direction. Simultaneously, we also have, like I just told you, we have quadrants, 45 degrees quadrants for all these, all right? So we call it as northeast, this is your southeast, and we have northwest and southwest. All right, in terms of number also you should remember them, because eventually you'll use that somewhere later in the chapters. So this is your 45 degrees, 90, this becomes your 135 degrees, this is your 180, this becomes your 225 degrees, this is your 270, because you're adding 45 to this. That's why these are called as quadrantal points, right? Quadrants, nothing but 45. So this is your 315. All right. So every direction has its reciprocal track. What do you mean by that? For an example, let us take reciprocal track is nothing but, let us say this is your eastern direction. For an example, this is your 090 degrees, or we call it as an eastern direction. Reciprocal, which is nothing but opposite. All right. Reciprocal is nothing but your opposite direction. So what is the opposite of east? Obviously you will say west, which is nothing but opposite of 90 is 270. So how do you get a reciprocal track? All right. So what you've done here, for an example, if not 90, I would take 080. So what is the reciprocal of 80 in that case? Let us say if this is 80, all right, I need to draw a reciprocal of it, which is exactly opposite to it, right? So any reciprocals, let us say this reciprocal, if you consider, all right, 90 and 270, the gap between them is 180 degrees. Similarly, if I consider reciprocal of this one, let us say 80. What is the reciprocal of 80? Again, I am adding or subtracting 180 degrees. So I get 80 plus 180 is nothing but 260. So to calculate or to find any reciprocal, you need to either add 180 or subtract 180. Why do I say subtract? Here is an example. So if I take 100 is your track, all right? What is the opposite or reciprocal of it? You wouldn't subtract. In this case, you will add 180. So if you add 180, it becomes 280. But if I take the direction 300, what is the reciprocal of 300? You don't add 380, right? If I add 380, how much does it be? If I add 180 in this case, it goes 480. But you have directions from 0 to 360. There's nothing called as 480, right? So this is the reason any number or any track that you see less than 180, all right? Any number that is less than 180, add 180 to it, all right? If any number that you see more than 180, let's say 300, 200, 250, in that case we subtract. We don't add in that case, we subtract 180. So in this case, how much it becomes? It becomes 120. Simple. A number less than 180 degrees, to find its reciprocal, we add 180. A number which is greater than 180, to find its reciprocal, we subtract 180. That is how simple you calculate the reciprocal tracks. Reciprocal track is nothing but opposite track. This concept we'll use later in this chapter. Okay, please remember. So we have cardinal points, quadrantal points. A direction goes from 0 to 360. There is no 361. It starts again from 0, 0, 1. Any clockwise direction increases its number. That is nothing but if an aircraft turns right hand side clockwise, the direction of the aircraft will increase. If an aircraft turns left hand side, all right, let's say an anti-clockwise motion, the direction of your aircraft decreases. Okay, that's how your aircraft flies following certain direction. Okay, so this is what you have in the direction, cardinal and quadrantal. All right, next important thing is something which is very interesting, that is called as great circle. You must have heard about semicircles, you have heard about circle, you have heard about different shape. But yes, this is something, a very interesting concept called as great circle. As you see the word great, the great man, the great sports player, is something which is big, which is popular, which is famous, right? Why it is called as a great circle, you will eventually understand. All right. Now, I'll give an idea why it can be called as great circle, what the word great here refers, right? Let's say I draw a few circles, right? I've drawn all similar, but something which is special, I must have highlighted to give a bigger and outlook picture. These are common, right? All of a similar size, similar shape, similar color, right? But here I have highlighted and made it different than other. I will call this as a great circle. Okay, you must have come across, if you watch a WWE, they call a great Khali, right? Similarly, the greatest is nothing but something special, something bigger in size, something unique, all right? Let us say for an example, if you consider this example of great circle on the globe, all right, let us take an example of this. Okay, so here, if this is the earth, I have taken a point A and I've taken a point B. And how do I connect them is, let's say I'm following a line. And this line covers these 2 points. So basically, this is a circle, right? Okay, if you imagine in a 2D or 3D shape, it is nothing but a circle which is bigger. For an example, if I take another circle from here to here, right? And if I draw a circle like this is also a circle. Even this could be also a circle, but these are smaller ones, right? This is not the biggest one. The biggest one is only a circle that is called as a great circle. Okay, this is by the idea, the term great means, great here refers to the biggest or largest possible circle, right? Now let us go to the definition of a great circle. Okay, if you see in the notes, it's quite self-explanatory. Largest, this is what I was saying about the word. The largest possible circle. The largest possible circle that can be drawn on the surface of the earth, which divides the earth into 2 equal parts. Okay, just imagine here you got a picture. Okay, if you see this one circle, I'm highlighting with the blue. It's kind of a ball, or you can talk about a watermelon, which is perfectly spherical. And you slice the watermelon into two equal half, right? So imagine a knife in the form of a flat circle. You're just chopping them into two equal half and dividing into two equal portions, right? So the biggest circle, all right, the biggest circle that divides the earth into two equal half is called as great circle. Let's say I am considering this circle, all right, this plane is slicing the earth, but not into two equal proportions, right? Let's say this is a 10 percentage, remaining is 90 percentage, right? So this is not dividing the earth into two equal part. So like I said, you great is nothing but the biggest possible circle that divides the earth into two equal half. Example that you can consider is here, equator, right? As you see in the example here, we have an equator that is drawn. Similarly, can I consider any other shape for an example of great circle? Let me tell you what does it mean here. So if you take it this as an example, here is a circle, here is a circle, right? And I'm drawing as an equator, you're slicing the earth into two equal parts. There is one great circle. Even this is slicing the earth into two equal parts. Even that is a great circle. Even if I've drawn vertically, this is also a circle dividing into equal parts. Need not to be always a north and south. It could be right and left. It could be slant. It could be anything. But it can't be this. It can't be something not dividing equally. It can't be something which is not dividing equally. Alright? These are called as small circles. But the one which is biggest, which cuts the earth into two equal proportion, is called as great circle. Now let us go deeper into the concept of great circle to understand it better. Alright? So we see here in the notes, they have selected 2 points. If you see here, let us say this is a point A and here is the point B. Okay, so what they're trying to do is they're joining these 2 points in such a way that if you draw a line, right, which is something an arc of a circle only, arc of a great circle only. All right, let me extend you this line. Okay, let me expand this line so that you have a better idea. So I'm continuing this circle, all right, which is further going behind the earth, but you're not able to imagine it. Okay, there's a circle which is still going behind, connecting these 2 points. Okay, let me tell you what does it mean here. For an example, okay, for an example, if I draw a picture, all right, and yeah, so what I'm trying to do is I'm drawing a great circle here. Okay, this is a bigger circle that I could draw, and which by definition can cut the earth into 2 equal half, can divide the earth into 2 equal half. Now select a point A and point B. So isn't it the point A and point B are on the same great circle? And what I'm trying to do is select this segment, this portion. This is an arc that I'm selecting. All right. So this is the part which is on the great circle between point A and point B. Right. Now this you relate to the picture that is given in your book. Okay. Here you have. Yeah. So similarly, these 2 points what is drawn on the globe, A and B, are a part of a great circle, right? Now, here you see the definition. The largest possible circle that can be drawn on the surface of the earth, which divides the earth into 2 equal halves. It has the same radius of the center of the earth, agreed? Isn't it? Whatever is the radius, let's say I draw this radius, it has the same radius of earth, right? This is important. It says it is the shortest distance on the surface of the earth between 2 points that are drawn. So if you see here, if I say this is a point A, this is a point B, this is the shortest possible distance, guys. You can't say this distance which is linearly going from A to B is shortest. Okay, it is not going to be possible. So when I draw a point on the globe, right? So let us say here is the earth. If I draw a point on this part somewhere, okay, so let us take these 2 points. And if you see this yellow line, It is dividing the earth into two equal half. Isn't it the yellow line? Can I say this yellow line which is going to form a complete circle? Okay, as you see further, it is a great circle, isn't it? Now if I select these 2 points, this is the shortest distance between these 2 points. You cannot go above, you cannot go below. The only way to go between these 2 points is a great circle. So any aircraft that must be flying. Obviously guys, when we discuss what is navigation, it is the shortest, safest, fuel efficient to go from A point to B point. All the aircraft usually follows great circle track. Why? Let's say if it is a Hyderabad and you're going to some other place, all right? The autopilot is following one track and that autopilot is always going to follow a great circle track. Reason? Like I said you, by definition, it is the shortest distance between point A and point B, right? If you see here in the example as well in your notes, yeah, just imagine, maybe not true, let us say this is your Hyderabad and this is the Delhi, okay? Not theoretically possible because I have placed them 2 different positions, one very low, one very high into the northern hemisphere. But ideally if you see, if I want to go from A point to B point, all right, would you follow a great circle track or a random track to reach to the point B? Obviously, you will always follow great circle track because this is the shortest. The great circle tracks are always the shortest tracks, so that's the reason most of the aircraft always follow great circle track. And all the autopilots that are designed and that are installed in the aircraft, they are designed to follow great circle track, and they usually do, right? So this is what about some points that you have to remember on great circle, right? So here are the few of the points for your exam point of view. It is the shortest distance on the surface of the earth between any 2 points, right? Only once great circle track is possible between 2 points. What does that mean? What does this point means? Let us say here is the earth and I select this point A and B. Okay, just like I gave you point A, point B. How many lines can I form between these 2 points? How many lines I can draw connecting these 2 points? If I connect, I've just drawn a point A. I can draw infinite line, isn't it? I can draw infinite lines passing through these points. You can draw several lines passing through point A. But what my question was, not just 1 point. I'm giving you 2 points. How many lines can you draw through these 2 points? You can draw only 1 line. The condition was to join these 2 points. Only 1 line can be drawn. Similarly, if I give you this position, you can only draw 1 great circle. Let's say this great circle is going in this fashion, all right, and this is going to be connecting like this. I can draw only 1 great circle unless these points are diametrically opposite. What does that mean again here is, let us say I gave you point A as here and point B as here. Now, how many great circles can you draw through this point? You can draw n number, guys. You can draw like this, you can draw like this, you can draw in plenty other ways, all right? All you have to do is connect them, right? So if they are exactly opposite of the globe, one being extreme right, one being extreme left, that are called as a diametrically opposite point. Not the point which are, on the same side. Let's say A and B is here, you can draw only 1 great circle. If A and B are on the ends of those points, okay, if A is here and let's say B is here, these are called as diametrically opposite. You can draw n number of great circles connecting those points. Okay, so if someone or if there's a question in an exam, how many great circles can be drawn through 2 points if they're on the same side? Only 1. If they're on the opposite sides where they are placed diametrically opposite to each other, then you can draw n number of great circles. All right. Well, so this was the point that I said you, and yeah, obviously there is again a point. Only 1 JC is possible between 2 points unless they are diametrically opposite. You can draw infinite GCs. Radio signal, or you can talk about your autopilot, or talk about many navigators that you follow, right? They always follow GC path. Radio signal, you transmit a wave, it wouldn't be going right and left or here and there. It goes straight, shortest, right? Again, that is a great circle. Examples, if you want to consider, for your understanding so far, is an equator, right? Equator divides the earth, as the word says equator. It equates into two proportionals, and that is why equator is considered as a great circle. We'll talk about meridian and anti-meridian soon, but so far you should have an idea about what is great circle, what is an equator, right? And for your understanding, you got a pictures here in the notes to refer them. You can go ahead with that. Now, before we come to the rhumb line concept, let me keep this aside. All right, we'll discuss this once we complete the small circle and other terms, so that you have a better idea of what the rhumb line could be. All right. So, if not great, if not the greatest, then what? It means it is a small circle. So, just if you remember what was great circle, it is the greatest or the biggest circle that divides the earth into two equal half. This won't be dividing into two equal half, right? This would be dividing some ratio of 75-25, not 50-50, you can say, right? So if you see all the circles, other than great circles, are eventually a small circle. What do I mean that is? If I say this is an earth, and let's say this green one is the great circle, which is dividing earth into two equal parts. And the rest ones that I'm drawing are small circles. 1, 2, whatever you can say, apart from equator or apart from this green line, all the circles that we draw, which doesn't divide the earth into two equal parts, becomes a small circle. Alright, so you must have got an idea about what small circle is. All the latitudes that you see, okay, all the latitudes that we see on the surface of the earth except in equator, let's say this is an equator. All the lines apart from this, alright, becomes eventually all the small circles. These are basically a smaller circles. Great. Yeah, any circle on the surface of the earth which is smaller than the great circle is called a small circle. Examples, all the parallel of latitude. Equator, by now you must know it. What is equator? It is a great circle or not? Yes, obviously. It is the great circle. It's a great circle whose plane, this is very important, guys. You can't say any plane that divides the earth into two equal half is an equator, right? What I mean to say is, you can't say anything that is dividing the earth into two equal half is an equator. Let's say with an example, if I say this is one circle and this is another one. This is an equator. Can this be an equator? Or can these be an equator? Let's say, can this be an equator? That is dividing earth into two equal half. All three are great circles because all three are dividing the earth into equal parts. But do you think all three are called as an equator, or can all three be called as an equator? No. Why? Because if you see by definition, the plane has to be 90 degrees to its axis, right? If this is an axis, its plane has to be 90 degrees to the axis, then it is called as an equator. Not any random great circle can be called as an equator. Please remember, that is very important by definition. Okay. So, whose plane is perpendicular to the axis of the earth is called as an equator, and obviously equator lies in which direction? East, west, right? So this side is in east, this side is in west. So direction of an equator gives you east and west direction. Important. What do you mean by meridian and what do you mean by anti-meridian? Okay, so if you see the globe, guys, all right, if you see those lines, okay, the line joining from North Pole all the way to South Pole, okay, if you see these all the lines that are joining from North Pole to South Pole, these curving lines you can see, those are meridians. Let me give an example by the diagram so that you can understand easily. Let us say this is the North Pole and this is the South Pole. And I'm joining a line, all right, from here to north to south. All right, I'm joining this line from North Pole to South Pole. Okay, this is meridian. So can I call them as half of the circle? Let us say if this is the North Pole, if this is the South Pole, I'm joining a line from North Pole to South Pole, right? Is it? The line that is connecting from North Pole to South Pole is called as a meridian. Can I call this meridian as semicircle, half of the circle? Yes. If this is the meridian, opposite of the meridian becomes an anti-meridian, still it is a meridian, right? A meridian is nothing but a line joining from North Pole to South Pole. Meridian and anti-meridian. Okay. The combination of meridian and anti-meridian are quite opposite. If one being on the right, extreme right, the other being on the extreme left. All right. So that is what the meridian and anti-meridian concept is. And these two lines connectingly going to form a complete great circle. These two lines completes a great circle. So what you can say is a meridian is semi-great circle. Semi being half. Okay, two semi-great circles can form one complete great circle. Let us discuss about this with some more examples in the later part, which can give you a better clarity on what is meridian and anti-meridian. All right. So, but it is quite easy. Half of the semicircle, I mean half of the your entire circle, there is nothing but a semicircle. Two semicircle forms a complete circle. Similarly, meridian is nothing but a half circle, half of the great circle. So two meridians, combination of meridian and anti-meridian forms a complete great circle. So let us continue this part in the next part of the class. Till then, we'll stop the topic here. Right.